So here are the solutions for problems 7 through 14 on your review. In an experiment, the control group should receive, it says treatment opposite, same treatment. So let's talk about the treatments. The treatments don't have to be opposite, just different. It could be a placebo is the best choice. And then if you look at D, it says a procedure identical to that given to the experimental group, except for a random decision on receiving the treatment under examination. So you have two groups. The control group, everyone in that group should not receive the same treatment as the other group. It could be a placebo. It could be no treatment. It could be you're comparing treatments. So A, B, C, and D are incorrect. C is correct. A procedure identical to that given to the experimental group, except for receiving the treatment under examination. Number 8. In a simple random sample, SRS, of 625 families who do not live near any chemical plants, 10 had children with leukemia. In a simple random sample of 412 families living near chemical plants, 15 children had leukemia. A 90% confidence interval of the difference in proportions is reported to be negative 0.0204 plus or minus 0.0173. What is a proper conclusion? Well, let's use the boilerplate for conclusions. We are blank % confident that the interval blank to blank captures our parameter in context. So the only one that looks remotely like that. We are 90% confident that the difference in proportions between families who do not live near any chemical plant having children with leukemia and families who live near chemical plants having children with leukemia is between negative 0.0377 and negative 0.0031. And I should clarify, how did they get these two numbers? So the first one is negative 0.0204 minus 0.0173. And for the second one, you just add 0.0173 to the negative 0.0204. So the correct answer is E. Number 9. In a study on the effect of music on worker productivity, employees were told that a different genre of background music would be played each day, and the corresponding production outputs noted. Every change in music resulted in an increase in production. This is an example of what? Well, the employees know that a treatment is being applied, so their behavior changes. This is called the placebo effect. Number 10. Which of the following are true statements? By the law of large numbers, the mean of a random variable will get closer and closer to a specific value. Really tempting to go with that one, but the true mean of a random variable isn't going to change based on sample size. Now, your statistic, your sample mean will get closer to the true mean as sample size increases. But this one isn't talking about the true mean, so we say false. 2, the standard deviation of a random variable is never negative. So let's look at a standard deviation. This is from your math chart on the random variable line. And there's no way for it to be negative. We're squaring the difference, and then we're taking the positive square root. So this one is a true statement. Then this says the standard deviation of a random variable is 0 only if the random variable takes a lone single value. Well, and they don't mean just one value in your sample or a sample size of 1. It's just you take the same value every time. If you take the same value every time, that means the value has to be the mean, which gives you a 0 in the formula, giving you a 0 for standard deviation. So both 2 and 3 are true. Number 11. Which of the following scatter plots could have resulted in this residual plot at the right? So first of all, I'm going to draw a line through it, and then I'm going to look at the residuals. On the first one, the residuals start out below, and then above, and then below. And that kind of fits our curve. See, it starts below, above, and below. For the next two, this one's above, below, above, and so is that one. So these don't fit that graph. And then for graph D, it's pretty close to a perfect fit. The residual should be close to 0. And so E is not right because we did find a fit with A. A is the correct answer. Number 12. Which of the following is a true statement? If bias is present in a sampling procedure, it can be overcome by dramatically increasing the sample size. There is no such thing as a bad sample. Well, okay, we can already see something wrong there. First of all, bias cannot be eliminated by increasing sample size. That's false. And 2, there are plenty of bad samples, so A and B are not correct. Sampling techniques that use probability techniques effectively eliminate bias. Well, we want randomization, right? Because we can see that D is incorrect because it says, oh, allow the surveyor to choose participants with care and precision. Well, we have unknown biases ourselves. And so sometimes you can't eliminate biases, for example, under coverage, unless you totally change the design. It really doesn't have to do with your sampling technique as it does with your sample frame. And then we want randomization because we don't want surveyors choosing participants because we have these hidden biases that we don't even know about. So E is the true statement. In choosing a sample size, actual sample size is more important than the fraction of the population surveyed. That is true. As long as we stay under 10%, we're good for most of our situations. Number 13. To test whether husbands or wives have greater manual agility, a simple random sample of 50 married couples is chosen, and all 100 are given a 1-minute period to find and place strangely shaped pegs into matching holes. What is the conclusion at a 5% significance level if a 2-sample hypothesis test results in a p-value of 0.15? Well, we actually have a natural pairing here of the married couples. So a 2-sample hypothesis test is not appropriate. That's only when the 2 sets of data are independent. So if I had 50 randomly selected men and 50 randomly selected women, that would work fine. But here I have a natural pairing. They are not independent. They're husbands and wives. So if one is athletic, the other one's probably more likely to be athletic as well. If one is younger, the other one's probably more likely to be younger as well. So there's this sort of relationship going on. So the only proper procedure we can do is run a 1-sample test for the mean of the differences of the paired data.